yeah, I remember I mentioned that they are very popular at the moment. And their functions, yeah. Yeah, and you think when we're talking about the basal ganglia, refer to the lessons in dysarthria, yeah. Okay. Yeah, and the basal ganglia deficiency associated with Parkinsonism. Yeah, you're right. Okay. Yeah. And there are mentioned research from many years ago, together with some more recent studies concerning a probable relation between stuttering and reduced dopamine production, like in the Parkinson's disease. Yeah. And the basal ganglia, they are the large masses of grey matter situated deep in the cerebrum, yeah, below the cerebral cortex. And the interesting part in the vast input to the basal ganglia of afferent information from all four lobes in the cortex. And the output from the basal ganglia is usually projected to thalamus, the brain stem, and to the corticomotor areas in the frontal lobe. Yeah. But the most important functions are the basal ganglia circuits. Yeah, they are very interesting because at least 4 functional circuits have been identified and associated with the basal ganglia structures. Yeah, and these neural circuits begin in the cerebrum, go through the basal ganglia structures, and then return to various areas in the cortex. Yeah. Okay, the loops, yeah. Yeah, and that's because they begin and end in cortex, they're often referred to as loops. And you remember what was discussed earlier by Nelson? Yeah. Okay. And the circuits traveling through the basal ganglia, yeah, and they are identified as the motor loop, the cognitive loop, the limbic loop, and the oculomotor loop. Yeah, and the basal ganglia connections with cortical nuclei and subcortical nuclei of structures such as the thalamus and brainstem form the basal ganglia control circuit of the motor system. Yeah. And these nuclei and their interconnections are part of the extrapyramidal system, you remember? Yeah. And they function in regulating and controlling motor movements and muscle tone, planning for movement and giving expressions to motor movements. Yeah. 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 And damage affecting basal ganglia function may result in movement disorders. Yeah, and you see clinical, either the underactivity of muscles, hypokinesia, yeah, and those, associated with dysarthria such as the Parkinsonism. Yeah, that you previously mentioned, yeah. Or on the other hand, the overactivity of muscles, the hyperkinesia, yeah, and this associated with dysarthria such as chorea and dystonia. Yeah. Yeah. Okay. Yeah, it's interesting. Yeah, I do agree with you. The recapitulating the dysarthrias and the neurology stuff. Oh yeah, and you wonder why these discussions of basal ganglia are connected with stuttering. Okay. Well, yeah. And you have the theories by Solly, Schilder and Seaman, and that was very old theories, probably before the early 1930s, who related stuttering to the functions of the basal ganglia. Yeah, and you can see a little bit of those discussions in Paran, yeah. But later on, Stromstad in 1986, who clinically compared stuttering with Parkinsonism and his neurophysiological research. Yeah, and you know, I think I would agree with you. You should read this book by him, Elements of Stuttering. Yeah, you know, and I refer to some of it. This is my report. Okay, yeah. But more recently, the refreshment of those theories, especially the dual premotor systems hypothesis by Goldberg in 1980s, now proposed by Alm as the fundamental causal mechanisms of stuttering. Yes, and this is a dual premotor system hypothesis, and this defines two parallel premotor systems, the medial, and that is the basal ganglia, and the supplementary motor areas, the SMA, yeah. And the other one is the lateral, and that's the lateral premotor cortex and the cerebellum. And by Goldberg and Alm, they are suggesting that stuttering can be caused by a disturbance of the medial system, in most cases in the basal ganglia. And this core dysfunction is proposed to be impaired GO signals from the medial system, supposed to trigger the next segment in speech. Yeah. And you see, under some conditions, speech control is shifted from the medial to the lateral system. And the lateral, you see the premotor cortex and the cerebellum, and then bypasses the dysfunction and resulting in fluent speech. Yeah. Yeah. Yeah, you see, because the lateral system, it seems to be active when speech is combined with sensory input, such as chorus speech or metronome, and these conditions we discussed before, such as singing or imitating dialects. Yeah, okay. And also, you know, the auditory feedback. And its possibilities of reducing stuttering, and that is proposed to be based on this mechanism. Yes. But you see, the lateral system, it's able to control speech timing without sensory input, but these demands increase attention to some particular aspects of speech and occurs in imitation of dialects, exaggerated rhythm, and reduced speech rate or role play and singing. Yeah, thing I'm doing right now. Yeah, okay. Oh, you mean if we cannot relate the cause of stuttering as a disturbance from the right hemisphere at all? No, I wouldn't agree to that for sure. I would rather interpret these findings as a part of the hierarchy of open closed loop systems. Yeah, and I see it more like a further development from Nelson's descriptions. Yeah, and actually I think that these controversies between the brain centralists and the basal ganglia supporters aren't that big now. No. Anyhow, no. Not that big as between the learning theory fundamentalists and fluency-oriented therapies in speech-language pathology. No, you can't compare them. Yeah. Yeah, and my support for this is that both directions have their common interest in neuroscience, and that's the same paradigm. Yeah, and they are open-minded to change their ideas in the light of new research. Yeah. Uh-huh. Yeah. Yeah. Well, you see, I think somehow that both directions are right. And that is why, as they propose the importance of the interaction between the motor system and the sensory feedback systems for establishment of fluent speech. Yeah. Okay. Yeah. And moreover, we have to keep in mind the brain as a cooperating network. And the small things that can interfere and disturb this balance of speech. Yes. And also, the structures mentioned by Alm for the lateral system, the facilitating system, where the lateral premotor cortex consists of Broca's area. And here we are. Yeah. No. Okay. No, don't get nervous. Yeah. You wonder if I'm talking about aphasia and stuttering. Well, you see, I'm explaining neurology. And when we are discussing speech motor systems, sooner or later we discuss the Broca's area, mentioned as a facilitator and a part of the lateral system. Yeah. And in the neighborhoods we have find structures from the medial system which can disturb the fluency. Yeah, and very close to the Broca you have the supplementary motor area and its connections with the basal ganglia. Yeah, and reading the different papers, I have understood it, if I have understood it right, the controversy seems to be concerning the role of the right hemisphere, if it should be regarded as an interfering troublemaker, causing disruptions of fluency, or a facilitator helping fluent speech. Yeah. Yeah, I agree to that. It seems to be a complicated story for us as speech-language pathologists. Yes, yeah, I do agree. We are more helped to receive support for our directions in stuttering intervention, helping our clients along. Yeah. Yes, of course.